Hey there, it's Jason from Codemanship with a video diary entry entitled, What is Dependency Injection? So there's been a debate raging on my personal Twitter account, just at Jason Gorman, if you want to follow me, about dependency injection frameworks and whether or not you really need them. My personal opinion is I've never needed one, although I've seen many teams use them for nefarious purposes. And when I ask developers, when I dig a little deeper as to why they use the frameworks, there's a genuine belief there, I think, among many developers, that dependency injection means using a DI framework. It's a similar thing to mocking. These are mock objects because I'm using a mocking framework, and sort of confusing the tool with the technique. So I thought maybe just give you a short overview of what actually is dependency injection. What do I and most other OO programmers mean by dependency injection? And to do that, I've got a simple example here. I've got a stock monitor class, and it's basically, its job is to decide whether or not to send restock alerts to the manager of the shop. So we make a sale of a product, and there's a reorder level that we can calculate for that product based on how long it would take to get more stock and how much stock we would sell in that same time. This was the lead time, and therefore at what level of stock should we place that reorder. And to do its job, it uses three other objects. There's an alert that it uses to send the alert. There's a warehouse that it uses to fetch the product information, like the stock level and the lead time. And there's a reorder level object that calculates the reorder level using that information, and historical sales data to determine how fast we sell that product, how many per day, basically. So it uses these three objects. As you'll see, it doesn't create those objects itself. Those objects are passed into the constructor. So we pass in, let's wheel my mouse along, pass in alert and warehouse and reorder. So it uses those without instantiating. And if we just dig a little deeper, we'll see that alert and warehouse and reorder level are all defined as interfaces. So stock monitor is only binding to these interfaces, only knows about these interfaces, doesn't know what the implementations of these objects are. And that allows me, for example, to test whether or not an alert is sent without actually sending an alert, so we're mocking that, without actually fetching real product information from the warehouse, where we're stubbing that using a lambda here, because in Java, if an interface only has one method, then you can treat it as a function. And again here, without actually knowing how we're calculating the reorder level or what the historical sales data is, we can just stub that and say, well, let's say the reorder level is 10, we've got 11 of them in stock, we sell one, so that should trigger an alert. And that's dependency injection. That's literally all it is. It means that dependencies are passed in from the outside. In languages that have binary compatibility and static typing, like C# and Java, that usually means we need to define those dependencies as abstractions, like interfaces. In dynamic languages that support duck typing, we don't even need to do that. Just as long as they look the same from the outside, it's all fine. So dependency injection just means passing an object to look from the outside like the thing that the class we're talking about is expecting to use, look the same from the outside, but then we can swap different implementations. Stock monitor doesn't know any of their implementations, and that's the important part. So we can swap those implementations, we can change those implementations however we like for all kinds of different reasons, like for example unit testing, and that allows us to achieve something called inversion of control. So if we had hard-coded dependencies, if stock monitor was actually creating an instance of an implementation of alert and creating an instance internally of an implementation of warehouse, then the order of method calls, which implementations call which implementations, is baked into the design. We can't change it. Inversion of control just means that order is determined dynamically by composition from the outside by the client. In this case, the test decides it's going to be a mock alert, it's going to be a stub warehouse and a stub reorder level. Stock monitor doesn't need to know anything about that. Doesn't need to know. So it allows us to change the order of processing in terms of which implementation uses which implementation, which method implementation calls which method implementation at runtime, allows us to compose that dynamically from the outside, and that gives us enormous flexibility in our designs, enormous flexibility. So no surprise that dependency injection is the foundation of pretty much all design patterns, all good OO programming, all good modular design. And not just OO, functions can be passed into functions as well. So it's not just an OO thing, it's a general modular design thing. That is all dependency injection is. In the years that I've been programming in OO languages, since sort of the end of the 80s, I've never needed to use a DI framework once. I have used them because they've been in code bases that I've worked on, but I've never seen the need to. It's like having a while loop framework. I can see the need for a while loop here, but I don't know how to write a while loop, so I'll use this framework instead. Instant water, you just add water. You've already got a DI framework in Java, it's called the JVM. Ditto with .NET and .NET Runtime. You've already got it. I've never seen the need for these frameworks. Now, you may disagree, and you're very welcome to disagree in the comments below. But before you disagree, just bear in mind that that is all dependency injection means. It's not about a framework. It's a very, very easy thing to do. If you're working on legacy code that has hardwired dependencies, that has those kind of dependency problems, then you could use a DI framework to work around that. But I kind of like my dependencies where the compiler can see them. So rather than working around the dependency problem, I refactor the code to fix the dependency problem. And if you watch previous videos in the Codecraft series, in whatever language interests you, you'll see there's a video on changing legacy code that involves introducing dependency injection to make legacy code unit testable. So it totally can be done. I find it quite cathartic. It's like popping bubble wrap for me. I quite enjoy doing it. I would rather fix the problem than rely on a framework. Same goes with many of these sort of power tools for programmers that work around dependency problems. Now, one last thing I'm going to show you in this little rant. At some point with inversion of control, somebody has to decide these are the actual implementations we're going to use. Someone has to wire all these objects in, a bit like Russian dolls, passing objects into objects into objects into objects and constructing dynamically the whole call stack in that kind of Russian dolls kind of way. So here's an example of an integration test where we've got a setup that is doing that. It's wiring in a whole bunch of implementations. There's a couple of fake things in there, but it's mostly implementations. Now, yeah, it does look ugly, but typically this kind of code would be contained in one place at the top of your call stack. So if it's a web application, it might be a filter, for example, an HTTP filter that constructs your call stack, your middle tier, before we actually process the web request. If it's a desktop app or a mobile app that's stateful, then it might be a composed call stack that's created at the top of the call stack when, for example, the application starts up. But typically, this kind of code would be seen in very small number of places. So yeah, and also a couple of people looked at this particular code. I posted a screenshot or something very similar, and they said, yeah, but Stock Monitor, its constructor has so many parameters. You need to read the code carefully. The indentation hopefully is a clue. Stock Monitor has 3 parameters. Alert, this product data thing we're passing in, which has the warehouse interface, and this lead time reorder level that has the reorder level interface. It has 3 parameters. Product data has 1 parameter. REST client has 2 parameters, and so on and so forth. If we take a look at our unit tests, we can see, or not that one maybe, we can see that the unit tests do not have those big setups. It's all very flat and small, like that kind of thing there. So our unit tests are small, and that's because we're using dependency injection so that they don't need the entire call stack. They just need a fake version of the direct collaborators for the class that we're testing. So there you go. That's dependency injection. It's the simplest of all the OO design patterns. It's not strictly speaking an OO thing either. You can do it in functional programming. You can do it in C. And it is the foundation of object-oriented and good modular design. It ticks the box of making our dependencies swappable for all kinds of different reasons. So whether you agree that you need DI frameworks or not, hopefully you're doing that now on the understanding of what dependency injection actually really is. Nothing to do with frameworks. Okay, there you go. Hope you're staying safe. I had my arms hurting today because I had my first vaccination. So light at the end of the tunnel, hopefully for us all over the next few months. But until then, Stay safe and see you soon.